Hello students, welcome to lecture 2, that is pipelining architectures. Okay, in last class we discussed what is pipelining and what are the how many types, what is the difference between non-pipelining architecture, what is pipelining, already we discussed. So pipelining is a process of arrangement of hardware elements of the CPU such that its overall performance is increased. Okay, and also we discussed without pipelining, or you can say non-pipelining, the execution time duration is what, 15 minutes, while within pipelining the execution duration will be what, 7 minutes. Okay, and also we discussed the design of pipelining. Number of stages are there, and in between every stages there is slice is there, and which is act as a input of S2. Okay, it will hold this slice, hold the input of output of the S1 and input for the S2. So these are the design of a pipelining, and also we can represent the pipelining by the help of space time diagrams. Okay, and also execution in a pipeline process, non-overlapped executions, overlapped executions. In non-overlapped executions, they require how many cycles, 8 cycles, but in overlapped execution it require how many cycle, 5 cycles. Okay, so then we discussed what are the different stages of pipelining. According to risk process, there is what, 5 stages of instruction, 5 stages are there to execute a pipeline, to execute a instruction in pipeline. So these 5 stages are what? Stage 1 is what, instruction phase. Stage 2 is instruction decode phase. Stage 3 is instruction execution phase. Stage 4 is memory access, and stage 5 is write back. Okay, so when what happen when we want to execute a instruction, first we have to fetch the instruction from the memory. After that we have to decode the instruction, what the exact value of the instruction. After that we have to execute the instruction in by the help of ALU. After that after execution of this instruction, if some instruction or some data required from the memory, we'll access that, and after that finally we store the output into the memory or registers. Okay, so these are the 5 steps which is used to execute a pipeline architectures. Okay, so now in lecture video 2 we'll discuss about what, again we'll discuss something details about the design of pipelining. Okay, so last class I told you there is number of stages are there. Assume that there is 3 stages are there, si plus 1, si plus 2. Okay, look, there is a input 1, this is the input 1, and this is the output of stage 1, and it is the input of what, first stage, and the output of the first stage, it is the input of second stage, similarly the third stage. So look, so this is what, this is called what, one cycle period, or one clock cycle period. This is called what, one clock cycle period, or denoted as what, tau, or we can say it is what, TP also, no problem. So what do you mean by tau? Now one phase duration plus one less delay. This is called what, less delay. This high frequency is called what, less delay, and this is called what, phase durations. So tau equal to less delay plus phase less delay plus phase durations. Okay, so the maximum, so so in pipelining there is number of stages are there, 5 stages are there. So look, if suppose multiple stages are executing multiple instructions, so we can't say that each and every stage takes same time to execute his instruction. Maybe instruction execution takes 2 minutes, maybe operand phase take more than 2 minutes. So always we have to take the maximum time to execute the all instruction. If you are not clear, uh, have a look. Suppose there is what, suppose there is what, one stage. Suppose there is what, one stage, another stage is that, and this is another stage is that. Okay, so some latches will be there in between the stages. Okay, so this stage what, in suppose in this stage, when will instruction, when will input a instruction to the stage, we can't say that each stage will execute in same speed. Suppose this stage taking what, 5 minutes, and this stage is taking what, 10 minutes, and this stage is taking what, 4 minutes. So look the difference is what. Now one stage is taking 5 minutes, another stage is taking 10 minutes, and another stage is taking 4 minutes to execute the instruction. So for in this case we have to take the maximum time as a clock cycle time. So that's why there is a formula is what, time period tau equal to maximum phase duration plus less delay. Maximum phase duration plus less delay. This is tau equal to max tau I equal to 1 up to k is what, number of phases, plus less delay. So this is called what, one clock cycle, or one clock period we can say. This is called one clock period. So this is the basic of designing a design of pipeline architecture.